Like any responsible collector of vintage computer equipment, and especially someone who has far too much stuff and definitely not enough space for it, I recently went on eBay and bought another system. It's in this styrofoam box that says Sinclair on it, and it's a ZX81. Now, this was sold spares or repairs, untested. It is the computer itself, a couple of cables, original power supply, and even a tape with a few games. But the other thing that I've bought is a new oscilloscope. I got this from AliExpress, and this only cost £40. So yeah, okay, it's not going to be the best scope out there, not by a long way. But I thought what we'd do today is let's see if we can figure out if our ZX81 works using a cheap scope from AliExpress. Now I know what you're thinking, why don't you just plug it in and see if it works? Well, one very good reason. We could do that, but the ZX81 only outputs an RF video signal, and I don't have any means of connecting that up. Certainly nothing handy anyway. Plus I've been looking a good excuse to use the new oscilloscope, so this seems like as good a time as any. Taking a quick look around the little computer though, well, it's got its membrane keyboard. If you thought the keyboard on the ZX Spectrum was bad, this is a whole other thing. It is just a membrane, so there is no tactile response to pushing a button, but it's all part of the ethos of this little computer. Keep it as cheap as possible. Sinclair wanted to make a computer that everyone could afford. There isn't much else to see on it, to be honest. There is an expansion slot here, and then it's just those ports on the side. RF output, ear and microphone inputs for connecting to tape deck, and 9V DC. Again, keeping with the theme of cost reduction, all three of those are 3.5mm jacks, mono jacks at that. No point in introducing a different type of jack for, say, the DC input. Keep the three of them the same, one less part to buy, more buying power, cheaper computer. It is missing its feet, but I'm sure we'll be able to sort that out easily enough. As I say, we've got the original power supply. Should be outputting 9V DC. We will test this in a minute. The plug on it is certainly showing its age. I may replace that. As the video cable, the RF cable, we'll probably not use this. But it does also have its cable for the tape deck. Although no tape deck included, I do have a spare deck that I'm sure would work with it. Although I know that itself doesn't work. So if we do get the machine to work today, if this does in fact work, we'll maybe try loading software by a slightly different means. There's the tape, includes the games Code, Asteroids, Bomber, Kaleidoscope, and Guillotine. No, sorry, Kaleidoscope isn't so much a game. It is a ZX81 simulation of the well-known toy. Could we call that a demo? That's certainly what it would appear to be. But yeah, unfortunately today I don't think we've got any means of actually trying to load from this. So just how much oscilloscope do you get for £40? Well, I assume this is it here. It is just a little handheld thing. And it comes in this nice little egg bag to protect it. There it is. Various buttons, I'm sure we'll try and figure out what all these do later. And power switch. Yeah, well, at least it seems to work. We have USB mini USB cable. The probe itself, we'll need that. A little screwdriver and some other little bits and pieces. And what looks like some instructions, but we're never too bothered when it comes to those. Let's just try and figure it out as we go. That goes on there. But first things first, let's open up our ZX81. Or in fact, no, before even doing that, let's see what the power supply is doing. Just going to mount this into the vise here. I think it will just make it easier to get our readings off the outputs on this, because it would be kind of handy to short between those two positions and potentially damage the power supply. I expect that the tip of it here will be the DC output, the 9 volt output, and this section of it here will be ground. And we'll take our chances with the plug as it is. So multimeter on, set to 20 volts DC. Power on, no explosions. What's it doing? 15.4. That seems like quite a bit. This is meant to be outputting 9 volts. Yes, there's no load on it. And these old power supplies, they do really need a bit of load to bring them down into spec. But 15, that just seems like an awful lot. I don't really know the architecture of the ZX81, but I would hazard a guess that it's fairly simple in here and it's all just running off 5 volt. So there's probably a 7805 regulator in here, and those things are usually good up to about 18 volts input. So it probably would be okay. But I think for now, to save risking any damage to this, we can just use the bench power supply to power up the board. But we need to get to that, so let's take this apart. 5 screws on the underside. So 2 gold coloured screws at the front and short screws at the front. The ones at the back are black in colour and seem to be longer. So the bottom cover comes off, revealing the rather small PCB. Just a further 2 screws holding this. And those are those goldy coloured screws again. And that is our machine out. Oh, that ribbon cable just fell out. Oh, it looks in a bit of a sorry state. Let me see if I can pull the other one out. Yep, that came out okay. And there is our little computer. The Sinclair ZX81 is all based around this, the Z80 CPU. And as I understand, in this machine is clocked at 3.25 megahertz. That clock is derived from the ULA here, Sinclair custom chip, which itself is also handling the keyboard and the video output. Just black and white video output on this and no sound. There's the ROM, all 8K of it, and over here is the RAM. These are two 114s, or 1K by 4-bit, obviously an 8-bit computer. These are 4-bit each, the two of those make the 8-bit. There is 1K of RAM. You might be able to make out here a position for a larger chip. I understand that it was possible that you could get a Sinclair ZX81 that didn't have the 2 of these, rather it would just have the 1, and it would be a 114, which itself is a 1K by 8-bit chip. This is the edge connector to which you would attach 16K memory expansion. It is indeed all running off 5 volts, as I thought. There is the 7805. So yeah, it probably would be okay to power this up off that original power supply, but I think I would rather just try and power it off the bench power supply first. So this jack is the power input. That is the positive side of the thing, and that buzzes through to there. That is the ground. That will be the middle pin. So that pin there has to be the output. Should be a 5 volt output. On the RAM, I would expect this pin to be the 5 volt input. And yeah, that is the case. So we can connect off our bench power supply to that pin there. Now, as for the ground, I don't really fancy trying to hook up to that pin there right beside this. I would most likely short something out. But that leg of that resistor that's very kindly sticking up in the air, that's also ground. And I can hook that up there. We'll set the voltage to 5. And we'll set the current to 1 amp. I don't think it will get anywhere near 1 amp draw, but let's just give it that anyway and see what it does. Output on. Okay, so it's taking about 0.4 of an amp. But is it actually doing anything? It's dropping off. I've got our probe all hooked up here. I just need to pick up ground, so I've just picked it up here at the same point. Let's start by looking at the clock pin on the Z80. That is on pin 6. 1, 2, 3, 4, 5, 6. So yeah, okay, the scope is showing something there. If you press auto, and there it is, there's our clock, and it's running at 3.24 megahertz. I'd say that's fine. If we just take a look right round this chip, starting from pin 1, we have address lines A11 through 15. So yeah, that looks okay. How do we adjust the scaling of this though? It's currently showing 1 volt per division. Okay, that's 2 volts per division. There's 5 volts per division, and it's peaking there at about 4.6, is that? See it flashing the 4.6 there occasionally? No, that probably is okay. It maybe seems a little bit low, to be honest. But my connection here isn't the best. All I said though, for an address signal, that looks okay to me. A12, 13, 14 and 15, yeah, they all look fine. There's that clock signal again. Then we're into the data bus. This is D4. That looks a bit screwed up to me, to be honest. Then it's D3, D5 and D6. The data bus is not looking healthy. Pin 11 is our VCC input, and then we've got the rest of the data bus. Pin 12 is D2, which definitely doesn't look right. D7, that's definitely not right. D0, that's the first one that actually does look okay, to be honest. And then D1, which doesn't look as bad as the others, but it still doesn't look right to me. Could that signify potentially bad RAM? The rest of the address bus is on this side of the chip, working from pin 40 down to pin 30. It is address lines A10 down to A0. And yeah, all of those look fine. And well, from that, I would sort of conclude that our ZX81 here is trying to run, but I think it's maybe got a problem. Those data lines did not look right to me. Is it trying to generate a video signal though? And it certainly does appear that way. We have a 15.6 kilohertz signal going into the RF modulator. So the next thing I would like to do is hook this up to a monitor and see if it's outputting anything. Okay, we know there is a signal there. There is something that the screen should be able to sync to, but is there anything on that screen? Now, as I said, this is just outputting an RF signal, and I don't have any means of displaying that, or well, nothing handy anyway. Rather, I think the best thing to do would be to composite mod this. Now, unlike the ZX Spectrum, which you can do a cheap and nasty composite mod just by cutting the input signal, basically disconnecting the modulator, just routing that input signal out the jack. Can't really do that with this. Rather, we need to build a little board that will generate our composite video signal. And I need to say a massive thank you to Lee from More Fun Making It, because he has sent me a little box filled with very colourful packing peanuts. It's definitely not as good as Flux Toast. Okay, that was a little joke. Please don't go eating packing peanuts, no matter how colourful they are. But in here we have a little bag, and in this little bag we should have a composite board for our ZX Spectrum. What's this? Kung Fu Flash? Bonus item 2? Bonus item 1? Lee! I was not expecting this. Bonus item 1 is Atari video composite mod. That'll be awesome. I assume I can use this with the 2600 because I have a 2600 and much like this, it only outputs RF. I need some way of getting a composite video signal out of it. Thank you very much, Lee. And bonus item number 2 is a Kung Fu flash. This is for the Commodore 64, isn't it? It's mostly populated there, just needs a couple of bits and pieces. Something on here, presumably a few switches. Another thing that needs to go there, and the main IC of it. This is awesome. I'm going to order up the parts that I need for these. Assuming, of course, that it's not included in here, because I thought all that Lee was sending me was this. This is the composite mod that we need for our ZX81, and there are the associated components for it. I will have to look up on the wiki for this just to be sure where everything goes. But yeah, this is fantastic. Thank you so much, Lee. I am honestly a little lost for words because I was opening this up expecting just to find this. I was not expecting to find these. I so really want to build this, but I'll have to wait for another day. Let's crack on and build this. So Lee has included more or less everything we need to complete the composite board, but we are missing one component. Capacitor C2. This is a 10 NF cap. And right enough, thinking back to the conversation that I had with him, he did say he couldn't find any of those caps, and I said, don't worry, I've got plenty of them. Well, you'll never guess what I don't actually have any of. Or well, none new anyway. I don't have any new 10 NF caps, but I do have a few old scrap boards. In particular, I do have one scrap Amiga 500 board. This thing itself does have a 555 timer on it. There it is there. And if we look at the schematic, for pin 5 of that, it also needs a 10 NF cap. That's that one, C713. We can recover the part we need from here. It wouldn't be a CRG video if I didn't get a bit of Amiga in it somewhere. Okay, all built and ready to go. But looking at the GitHub, we might not actually need that 555 timer. The whole point of having this is to produce the back ports for the video signal, but it does say on the wiki that it will work with the later 2C210 ULA. However, this ULA does provide a back port signal, so the 555 chip is not needed. And our ULA is a 2C210E, so in our case, that chip will not be needed. So this has to go in here, but I first of all need to strip that board out. Need to get that out of there. Well, after much pokery around this, I decided I needed to remove the RF modulator. And just as well, because there are solder joints on the bottom of the modulator onto the can of it. So if you want to do this, you need to take this off. And look what I discovered. On the silk screen underneath the modulator, it says Sinclair. I'm sure everyone who has a ZX81 knows about that, but I just thought it was pretty cool. Well, that's it done. The composite mod is installed and ready to test. It is tricky enough to get into there. That new board has to go in the same way the old one came out. That's in from below. There are a couple of solder points on the bottom of this, much like they were on the bottom of this original one. Those have to be made off onto the can of the modulator. That's how this board gets its ground. Beyond that then, there's just the two wires, the 5-volt supply and the signal. And then obviously the signal out, the composite video out, that just hooks up to the jack. So we can test it. That goes in there. Power and ground. And what's it doing? Hey, that doesn't look right. Corrupt the screen with a rolling image. Yeah, it's definitely screwed up. So it's not working, but why is it not working? Well, do you remember earlier when we looked at the data bus? It all seemed a bit screwed up, and in particular, data lines D2 and D7. So let's take a look at data line D2 on the CPU. That is pin 12. So it's floating there at about 1 to 2 volts, and there isn't really any activity on it. There are a few little spikes, but that does not look like a healthy data signal. If we go over to RAM chip IC4A, D2 presents itself on pin 11. And that looks completely different. In fact, you could almost say that looks almost correct, but it's almost like something is interfering with the signal. If I look at pin 13 on that chip, that's more what I would expect the data bus to look like. Going back to pin 11, it is similar, but just doesn't look right. Now pin 12 in between them, it's a complete mess. But let's just concentrate on that data line D2 for now. So it almost looks like it's trying to run correctly, but something is pulling it down. Now if we follow that data line to the ROM, D2 is on pin 11, and that looks exactly the same as it does on the RAM chip. So what about on the ULA? How does it look on that? D2 is on pin 28. So there it is there, and it looks the same as it does on the CPU. So why would it look like that on those two chips, but on the ROM and on the RAM, it looks like that? Well, the only component that sits in the way is a 470 ohm resistor. That's these here. There is the signal before the resistor. There is the signal after it. The resistor does read correct on the meter. It is 470 ohms. So to my mind, what this is showing us here is that the fault might actually be within the CPU or the ULA. If it's the ULA, well, it's game over, I'm afraid, because I definitely don't have a spare one of those. Could it be the CPU? Because one other thing to note is that this CPU, it gets hot, ridiculously hot, like almost burn you hot once it's been on for a minute or two. The only spares that I have at the minute for this machine would be the CPU or the RAM. I was initially leaning towards this might be a memory fault, but I think I want to try swapping out the brains of the operation. See, before I do just jump in and start removing things, so I just had a thought. There is a spare to 114. If I piggyback this RAM chip, because it's this one that shows the problems on its data bus. If I turn things on, there's that data line we were looking at. There's the next one beside it, also screwed. That one looks okay, to be honest, as does that one. If we look over on the other RAM chip, looks fine, that looks fine, that looks fine, and that looks fine. So we've got two bad data lines on this chip. If I piggyback this, well, it doesn't change what we're seeing on the meter. But it is changing what's happening on the screen. If I take that off, boots, and it's got all that corruption. We stick that on and power it up again. It just boots to a grey screen straight away. Now, okay, it's not booting, but it's not showing all that garbage. Take that off, power it on, there's the garbage. Put that back on and power it up, clear screen. Well, clear-ish anyway, there's jail bars on it, but you know what I mean. That's the old chip out, but one thing just to note, as you can probably tell, there is no solder mask on the top side of the board. All the traces are just coated with solder, and so it is very, very easy to bridge something. So just after taking the chip out, I just went over everything here with the solder braid, just to make sure that no stray solder got onto anything that may potentially cause a short. But it's all been wicked up, everything has been cleaned. Let's put a socket on, and then we can try this board with that other RAM chip installed. As per usual, we'll just do opposite corners of the socket first. Then I can hold it from the underside, remelt that, push against the socket just to make sure that it is sitting flat. Try not to burn myself in the process. Yep, I think that's sitting okay. So let's just do the rest of it. Right, socket is on. I've got power hooked up, as is the scope. Let's start with the original chip, just to make sure the behavior is the same. Data line D2. Yeah, that just looks the same as it did before. Over on the CPU, it is just that sort of flat line. So let's swap out to the other chip. Does this make any difference? Data line D2. No, that still doesn't look right to me. It does look different, but it doesn't look right. Still just looks the same over on the CPU. So I do know that is a brand new chip, because that's actually a spare color RAM chip that I had bought once for a Commodore 64. It is the same part, a 2114 1K by 4-bit RAM. Will we try swapping out the CPU? What's it doing on the screen? Let's just have a look at the screen. I didn't do that. So yeah, just a grey screen. Let's power cycle. No, it is still booting with that corruption. But said corruption isn't staying on the screen for just as long. What does that mean? Probably very little. Well, I've removed the CPU and fitted the socket. Same as last time, let's just put the original chip back in, just to make sure everything is still behaving the same way it was. So looking on the scope at data line D2, and yeah, that's still a bit screwed up, as is D7. We change out to this chip, which I actually had to pull from my ZX Spectrum. But that machine works fine, so we know this is good. Does that make any difference? D2. Hey, that looks more like it. What about D7? And yeah, this is looking good. What's it doing on the screen? Okay, we've got a white grey screen with a K in the bottom left. That's what our ZX81 should boot to when it's working. The image is a bit hazy though, isn't it? It's not the best of image. Wonder is that maybe down to these wires that I used? Are those wires maybe just a little bit too thin? But we'll not worry too much about that just at the minute. The more important thing is this seems to be working. Let's go back to the original RAM chip. Because you know what? I think that the fault here has been this CPU all along. Power up. And yeah, it starts up again fine. Let's just take a look at the data bus on this chip. D2, D7, yeah, they both look fine. As do the other two signals. Is that it? Have we fixed the ZX81? I suppose the real test would be to put it back in its case and see if the keyboard works, but also try to load a bit of software. Okay, all back together, let's test the keyboard. Now, I have to use the power supply, the original power supply. We seen that outputting just over 15 volts earlier, and I thought probably a bit high, didn't really want to risk it at the time, stating that the 7805 in here could operate up to a maximum of about 18 volts. Well, double checking that, those things should be good up to 25 volts. In fact, some of them are good even up to 35 volts. So 15 volt coming in, it'll be fine. And in fact, running off the power supply almost seems to have improved the image quality slightly as well. But what about the keyboard? Does it do anything? Well, that button did something. Q doesn't work. E doesn't work. It almost seems as if every other key doesn't work. Yeah, most of them don't seem to work. I was just about able to get the two ribbons back into the connector, but the one ribbon, the smaller ribbon, remember when we took this apart, it just fell out, it just popped out. It's a bit wrinkled, and I wonder, is it maybe broken? Just had a thought. Who remembers these things? I made these on the channel quite a few years ago now, but this is a homemade ribbon cable for a CD32. But if I peel that off, that's like a bit of plastic, sticky plastic that's used to stiffen the ribbon cable. Let's see if I cut this down to size roughly. The connector here only makes contact to the ribbon on the top side, looking at it there. So if I stick this onto the back of this, would that strengthen it enough just to allow me to push it down into there? Yeah, perfect. Suppose we may as well just put what's left of this onto this side of it. Is that another Amiga component used in the resurrection of a ZX81? Looking good. No, this bit of the keyboard still not working. G works, no H, J, K, or L. B, N, and M are also not working. Ah, it was looking so good there. Okay, one possible solution. We can cut this bit off. I'll take my little stiffeners off though, because I'm going to try and reuse those. Well, let's cut off the affected bit, and then I will need to sort of make that connector again, that edge of it. One fully working keyboard. So I suppose the last thing we should try and do today is run a bit of software. This is the tape that came with it. As you know, it's got those 5 games on it. In fact, it's actually got 10 on it, as well as those 5. It's got Klingons, Crashland, Simon, Artist, and UFO. Now, as I said earlier, I don't have a tape deck, or certainly I don't have a working tape deck that we could try and load from. But if we hook up the earphone, plug that in there, and then take this and plug it into my phone. Remember when phones had earphone jacks? And then using a bit of software called Play ZX, we can load the digital tape image into our ZX81, or at least I hope so anyway. I have the Kaleidoscope demo on this, same one that is included in this. So let's see if this works. So the ZX81 employs the same keyboard shortcuts that you'd find on the ZX Spectrum, or should I say the ZX Spectrum uses the same as this because this came first. Just press J, which is a shortcut for load. Then within quotations, it's the file name, which is Kaleidoscope. Close quotes, function new line. We do lose the video signal. Turn the volume up in my phone and go. 12 seconds long this. I get the distinct impression that didn't work. Earphone input is here. If we just bring up the schematic, you can see there from the input we should have a resistor giving us 220 ohms to ground. And yeah, we're pretty much bang on that. The signal comes in there to this component. On the underside of the board it is linked through to that position. That is the 220 ohm resistor. This though, there's a resistor in here, and if we look at the schematic, and in fact the marking on the board, the silk screen on the board, it shows that as C10. Should be a capacitor, that should be a 10 NF cap. Beyond this there is another resistor, a 4 0.7K, which is this one here. And that links us to pin 20 on the ULA. And yeah, that is correct. This thing though, this is not right. And if we look at the bottom side of the board, it's the component between those two solder points. And certainly that top one, that looks like it's been reworked at some point. So has somebody been in here and replaced a capacitor with a resistor? Okay, capacitor fitted in there in place of that resistor. That resistor, which by the way just fell apart when I took it out of the board. So potentially always an issue in there, but what was it even doing there in the first place? Now, just to give us the best chance at success, how about a bit of contact cleaner up in there? And let's even spray a bit on a cloth. And just go over the end of this cable with it. So power up, load, 2 of those, new line, and play. Well, it's brought us back to our grey screen with a K on it, but now what? Run? Nope. Is there even anything there? List? Nope. There are some settings within this software here on the phone, so we can turn the playback volume right up. It's on mono. Probably best to leave it on mono. It's a mono jack. Normal speed or turbo speed, let's just leave it normal. And natural wave or square wave. Let's try it with a square wave. It's just doing exactly the same thing. Could it be something to do with this? The audio settings of my phone. Let's turn off Dolby Atmos and DSEE Ultimate, whatever that is. One more try. Load. 2 of those. New line. Play. Nope. Still not working. Turn the phone right up. Is that going to make any difference? Come on. It's infuriating, isn't it? I assume there's still nothing there. Yeah. Nothing there. I'm not convinced that there is a further problem with the ZX81. I think it's just going to be this software and trying to get the phone to play back the audio signal at levels that this thing likes. Oh, it's working! Is it work? It's working! So all I did there was turn the phone down ever so slightly. Fantastic! Yes, that's all it was. Well, obviously that, and that resistor, which seemingly had no business being in there. But it's working. It loaded Kaleidoscope. So while it's drawing a pretty picture for us on the screen, how about just give the case a bit of a clean. Not that it was particularly dirty, but just brings it up a little bit. The text here, ZX81, that should be red, but obviously it's partly worn here. So I need to have a think about how to restore that. As I did say earlier, it is missing its feet, but I'm not going to put them on just yet. I do have little feet that would suit it, but that would cover 3 of the screws anyway. We're definitely going to need back in here at some point so that I can do a couple of modifications. One such thing that I want to do is a 16K RAM mod. Now we could just get the module that plugs into the back, but that's always a bit hit and miss, as in if you sneeze too loud while trying to run software that's using the memory expansion, well, you might upset it. But an internal 16K RAM mod, that would be certainly more permanent. So there's that to do. But what other type of mods can I do to this? Is there any means of adding sound? Is there even any software that supports sound? As I said, I'm not really familiar with this little machine. Well, that's it. We have one fully working ZX81, but let's not forget about the oscilloscope, the handheld £40 scope from AliExpress. Well, it worked fine, didn't it? It showed us all the waveforms that we needed it to on our 81. So far, for an 8-bit computer, this is grand. It will be interesting to see when we move up to the 16-bit computers if this still works as well. The literature for this, or the advert for this, did say up to 120 megahertz. I would maybe doubt that claim, but I haven't tested it, so I can't say for sure. It helped us today, and yeah, I can't really complain about it. Also, just to say thanks again to Lee from More Fun Making It for the Kung Fu Flash and for the Atari Composite board. I have ordered the bits and pieces that I need to build the Kung Fu Flash. So we'll maybe do a quick video on that when all that stuff arrives. I'll leave links in the video's description to Lee's channel. Make sure you go and check it out. But that's it for today. Thank you very much for watching, and I'll see you next time.